Hey, welcome back, everyone. Hope you all have had a fantastic weekend. The weather was exceptional, so my family and I spent a lot of time outside. Hope you all enjoyed your time and are ready to get back at it. We are in lesson 7.5 for the quadratic unit, or second quadratic unit, really. We are nearing our test. Remember, an email went out this past, I don't even know, maybe a week and a half, announcing that we are going to have Unit 7 tests the week of May 11th. It looks like it's going to be the 13th and 14th. We're going to have a couple different testing options. You'll get an email about that soon. Anyway, one quick question for you, and then we're going to jump in. What part of yourself are you working on? What aspect of you are you working on? For me, I feel like my kids and my wife deserve the best version of me. So I'm always trying to work on things. So curious what you all are doing. If you're not working on yourself in some way, trying to improve some aspect of your life, of who you are, I would ask, why not? Okay, let's jump in. All right, so this lesson 7.5. Now, this is really part two for us. For some other people, part two was the quadratic formula song, some other teachers, but we did that first. So this is part two for us, and that will be identified on Google Classroom as such. Okay, so let's read through this. It says use the discriminant to determine the number of real solutions. That's what we did last time in 7.5 part 1. Then we're going to solve using the quadratic formula. And then we're going to write our solutions in simplest radical form. So we're not going to approximate here. Okay, so let's just jump right in. I'm going to work 3 of these questions, and then I'll work probably this last one on a separate video. If you are interested and you need more help, you're welcome to look at this, okay? All right, the discriminant is b squared. I should write it here, b squared minus 4ac. It's the part that goes under the radical in the quadratic formula. So b squared minus 4ac, we're going to go ahead and calculate that. Remember, we've got our a, we've got our b, and here our c is on the other side, so we really need to subtract 14 from both sides, okay? And I'm going to rewrite this, so we'd subtract 14 from here. So this is 2x squared minus 3x minus 14 equals 0, right? So now this is in standard form. It's equal to 0. That's exactly what we need to do to apply the quadratic formula. So now we have all of our values, and this negative 14 is our c. So b is negative 3, so I'm going to say negative 3 squared minus 4 times a, which is 2, times c, which is that negative 14. Okay, this is 9. A negative and a negative are going to make a positive. Okay, so the product of these 3 numbers is 112. Okay, and I already did that on the side. The sum of these 2 numbers is 121. Okay, so from our last lesson, we know that if the discriminant is greater than 0, we will have 2 solutions. Okay, 2 real solutions. Now we're going to go find them. So the quadratic formula is as follows. So x equals negative b plus or minus the square root of b squared minus 4ac all over, or all divided by 2 times a. So let's plug these values in. So negative b, well, b is also negative, so I'm going to put that in parentheses so I don't forget one of those 2 signs. Plus or minus the square root. Well, the good thing is this b squared minus 4ac, that is the discriminant. We've already solved for that, so that's 121. So 121 all over 2 times a, which is 2. I'm going to come down here. So minus a negative is positive 3. So x equals positive 3 plus or minus the square root of 121. This is nice because 121 is a perfect square. So that's going to be 11. And we're going to divide that by 2 times 2, which is 4. Okay, so I'm going to rewrite it right here. So 3 plus 11 divided by 4, and then 3 minus 11 divided by 4. Now, when I go do that math in the calculator, I get 2 different solutions. Okay, and I already knew that I had two solutions. So one solution, 3 plus 11 is 14 divided by 4 is 3.5, and that's going to be paired with a y value of 0 because all solutions are. These are crossing the x-axis points. Okay, and then 3 minus 11 is negative 8. Negative 8 divided by 4 is negative 2 and 0. So I'm going to rewrite this up here. 3.5 was the answer there, and this is negative 2. All right, I'm going to draw some arrows so you can see these. All right, so we used the discriminant first, found that it's 121. That told us we had two solutions. And then we used the quadratic formula to go find those two solutions. Let's do this second question. Okay, so the discriminant, b squared minus 4ac equals 6 squared minus 4 times 3, which is our a, and our c, which is 5. All right, I'll label these a, b, c. Now this one was already in standard form set equal to 0, so we're perfect there. All right, so 6 squared, so 36 minus the product of these three, 4 times 3 times 5 is 60. So the total here is negative 24. Okay, so from lesson 1, if our discriminant, which is this thing, is less than 0, we have no real solutions, right? So 0 real solutions. And if that's the case, there's no point in doing the quadratic formula because when we get to this part, so negative b plus or minus the square root of, well, we found this to be negative 24 all over 2a, right? Well, we learned earlier in this unit that we don't take square roots of negatives, okay? That is an imaginary number, and we're saving that for Algebra 2, so we're not going to touch this, okay? This problem ends here, 0 real solutions. So what that means, if you're looking on some graph, it's some quadratic function like that, right? It does not cross our x-axis. So no solutions there. All right, last question we're going to do here is this one on the bottom left. Okay, I'll do this one in a separate video. All right, same thing. Discriminant is just b squared minus 4ac equals, and I'm just going to plug these things in. So b is 2, so 2 squared minus 4 times a, which is 6. I'll label these a, b, c, and c, which is negative 3. Okay, so we've got 4, and then 2 negatives will make a positive. So 4 times 6 is 24. 24 times 3 is 72. We knew it was going to be positive, so I'll write it down as that. And then 4 and 72 make 76. Okay, so if a positive discriminant, then we have two real solutions. Now we're going to use the quadratic formula to go find those solutions. So x equals, from our wonderful song and all of your different versions, negative b plus or minus the square root of b squared minus 4ac. That's our discriminant, all over 2a. We can just kind of jump quickly into this part because we've already solved this. That's the nice part. So negative b, well, b is positive 2 up here, so negative b will just be negative 2, plus or minus the square root of 76, because we found that, all over 2 times a, so 2 times 6 is 12. Okay, now our directions said to leave it in simplest radical form. So we needed to take this 76, and if we took the square root, it would be a decimal. Okay, so 76 is not a perfect square. So I'm going to come down here, just try to help you out. So 76, I'm going to break it down using the factor tree. This is one of the things I did in one of our previous lessons. So because it's even, I'm going to break it down. So I think this is 38, if I'm remembering correctly. So that is simplified. We can't break that down anymore. This is even again, so this is 2 and 19. All right, so we have a pair of these. So 2 times 2 is 4. The square root of 2 of those is just one of our 2's, okay? So we can factor that out. So I'm going to bring down here this thing. So negative 2 plus or minus, well, we've got a pair of 2's, so we can take that out, right? That's 4. So the square root of 4 is one of these 2's. So I'm going to take that out. And I'm going to rewrite it up here in just a second for you. Now 19, we don't touch that. That's a prime number. So we're going to leave it just like that all over 12. Now, just to show you kind of where this came from, we're going to rewrite -2 plus or minus the square root. And we basically found two factors. We found 2 times 2, which is 4. And we found just the 19. Okay. Well, we can take the square root of 4. That gave us the 2. But the square root of 19 is not a pretty number. So we're just going to leave it under the radical. So let me put that over 12. Okay. So our two solutions are bound up in this thing. Okay. I'm going to separate them so we can see it. So -2 plus 2 square root 19 all over 12. That's 1. Okay, and that would be paired with a 0. And then our second solution is this thing, but the subtraction piece. So -2 minus 2 square root 19 over 12. And again, that's an ordered pair, and that's really funky to put in there, but that is an x value. We don't know what it is. We're not taking the time to look. Okay. All right. If you don't need any more, then don't worry about this second video. But I'm going to make one more short little video covering this. I want to get you guys out of here and on your way. The homework. Let me jump over to the homework. Okay. Here it is. Okay. So it's got 4 examples, just like we did on the lesson. Okay. So you're going to find these. Now, the most important one, and what I'm going to have you turn in, is this right here, okay, the error analysis. Okay, so I'm going to want you to write this question down. This is what you're going to submit, the error analysis. So I'm going to need a list of errors, right? So number 1 would be blah, 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 right? Number 2, here's what they did, okay? But make sure you write this thing down in your own handwriting, okay? So this particular question is what you will turn in for this assignment, just number 5. You can't really do number 5, though, without all of this practice. So I would go practice these 4, just like the lesson, and then you can look critically at this piece of work and list out the errors that this particular person made. All right, everyone. I hope you all are well, staying healthy, getting outside, getting some sun whenever possible. Have a great Monday, Tuesday, and I will see you all on Wednesday or on the Monday at 1 o'clock Google Meet, which is basically to make sure that you understand what's going on here. All right. I miss you guys. Hope you're all doing well. Take care.